Welcome again to our class. Today, we are going to look at a topic in statistics, and this topic is central tendency. We have looked at various other topics in Introduction to Statistics, and this topic are building up on how we do analyze our data in the social sciences, more particularly in education planning. And today's topic is very important because the knowledge we gain in this area, we will build on this knowledge in our analytical work later. But before we move on, I'd like to revisit the previous topics we have dealt with, especially in the area of descriptive statistics, because the descriptive statistics itself is very important for us. As I said earlier, descriptive statistics can be used to explore and understand data, identify the patterns, and even communicate the key findings. It involves various measures and techniques that summarizes and describe data, and these include measures of central tendency. And when you talk about measures of central tendency, we mean we are talking about the mean, we are talking about the median, and we are talking about the mode. Also, when we are dealing with descriptive statistics, we are looking at the measures of variability, which include the range, the variance, and the standard deviation. Also, when we talk about descriptive statistics, we're looking at about the shape, the measures of shape, and the measures of shape of the statistics we are handling. We're talking about the skewness and the kurtosis of the data, the pickedness of the data, or the flatness of the data is what we call kurtosis. Now, skewness is whether the data is skewed towards the left-hand side, or the data is skewed at the left-hand side, or the data is normally distributed. Also, when we talk about descriptive statistics, we are talking about the graphical representation of this data. How do we represent this data on a histogram, on box plots, and on scatter plots? The primary goal of descriptive statistics is to provide a clear and concise summary of the data set, enabling researchers, analysts, or decision makers to gain insights and make comparison and draw conclusion about a data set. It also enables the researchers, analysts, and decision makers to uncover patterns, trends, relationships within the data that facilitate decision making, problem solving, and hypothesis generation for further statistical analysis. In statistics, central tendency refers to the measure that aims to summarize or represent the central or the typical value of the data set. This provides a way to understand the overall pattern of the central location of the data points. Central tendency measures are crucial for gaining insights into the distribution of the data and making meaningful interpretation. The concept of central tendency is used to answer questions like, what is the typical value? What value represents the sender of the data? What value can be used as a reference point to understand the data set? And by identifying a central value, we can better understand the characteristics of the data and make comparison and even draw conclusions. There are several common used measures of central tendency, and they include, as I said earlier, mean, median, and mode. Each measure has its own strengths and interpretations, making them suitable for different scenarios and types of data. The arithmetic mean, and I emphasize the arithmetic mean now because I'm becoming more specific, calculates the average value of the data and is often used with interval or racial data. Here, it's very important for us to know that the mean, if we have the interval or racial data, we can easily use the mean. On the other hand, the median represents the middle value of the data set when ordered. So we must order the data from the least to the highest, or from the highest to the least. Then we can now get the median from the data. And this one uses ordinal types of data or ordinal level of data. Then we have the mode. This one identifies the most frequent occurring value and is often used with the categorical and nominal data. So you see, when you choose a type of central tendency that you're going to use in the analysis of your data, then you must also be aware that the level of measurement or the level at which you're measuring your data becomes very important. For example, mean, you'll have chosen that your level of measurement of your data should be at the interval or ratio. And when you are going for the median, you should know that the level at which you're measuring your data is either at the ordinal level, and finally, at the mode uses the data that is categorical or nominal in nature. Choosing the appropriate measure of central tendency depends on the nature of the data, as I've said, the researcher question and the research question at hand. It is crucial to consider the characteristics of the data, such as the skewness and the outliers, as well as the desired interpretation of the central value. In statistics, various symbols are used to represent different concepts and different variables. And I want us to look at these symbols because I've seen students when presenting their work, their research work, they confuse these symbols. They might bring one symbol that is actually representing the population, and in their place, they are dealing with a sample. So it's very important for us to understand these symbols so that when you are representing our data or our statistics, we are not mixing up concepts. These symbols are commonly used across various statistical formulas, in various statistical equations, and in various statistical notations. The symbols are used to represent statistical parameters, population characteristics, and also sample statistics. The symbols help to distinguish between population level measurements and also sample level measurements. When performing statistical analysis, these symbols becomes very important. And the first one I'm going to look at is mu. Mu, written as u, but it's not you. The one we are having here and pronounced as mu. This symbol represents the population mean. It is used to denote the average value of the variable in the entire population. So when you are dealing with a sample, don't use mu. But if you are dealing with the entire population, use the symbol mu to denote the mean of that population. Second is what we call sigma. Sigma. Sigma represents the population standard deviation. If you want to calculate this standard deviation of the population, entire population, use the symbol sigma. Now, it indicates the measure of variability or dispersion of values in the population. The third one is the capital N. Capital N. This capital N, I've seen students confusing it with small n. So this capital N is a symbol that represents the population size, and it denotes the number of individuals or elements in the population. So when I see N as a researcher or as a statistician, I'll simply know that you are dealing with the entire population. Another symbol I want to look at is X bar. X with a bar written on top of it. X with a bar written on top of it. This symbol represents the sample mean. So when I'm using X bar, I'm simply representing the sample mean. The other one I want to look at is S, small s, not capital S. This symbol represents the sample standard deviation. Remember, there is another one that it looks like this one, but it's the sigma. When you use sigma, you are representing the entire population. But when you use the small s, it means that you are looking at the sample standard deviation. Small n. Small n. This represents the sample size. When you use small n in your population or in your formula, in your calculation, it means that this is the sample size as opposed to the capital N. P, small p, when used in the formula, this symbol represents the population proportion. Population, proportion. It is used to denote the proportion of the specific characteristics in a population. And when you use p hat, a p with a hat written on top of it, p with a hat written on top of it, this is a symbol representing the sample proportion. Sample proportion. Sample proportion. Now, this one denotes the portion of the specific characteristic in a sample. Then we have sigma. The final one I'm going to consider is sigma. This symbol represents the sum. When you see this symbol, it simply means that have the sum of the item represented. Those are the symbols, and hope when you are using them in statistics, please use them appropriately. Don't mix them. Don't put capital N in place where you're supposed to put small a. And don't put delta in the place where you're supposed to put small a's. go back to measures of central tendency. They are also known as statistical average. This tells us the point about which the item have a tendency to cluster. It is also considered as the most representative figure for the entire population data. So this, when we talk about central tendency, we are talking about mean, we are talking about median, mode, and these are the most common use measures of central tendency. You'll allow me now to start looking at each of them, and I will start with mean. Mean, there are several types of mean that are used in statistics. And the commonly used types are, the first one is arithmetic mean. The arithmetic mean is the most common used mean in our daily lives. It is calculated by summing up all the values in a data set and dividing the sum by the total number of all the values. We are going to do several examples of how to calculate arithmetic mean. Apart from arithmetic mean, we have geometric mean. Geometric mean, the geometric mean is used when dealing with exponential growth rates or multiplicative relationship. Multiplicate from the word multiplication. It is calculated by taking the nth root of the product of the nth values. The geometric mean is commonly used for calculating average growth rates, investment returns, or when analyzing with that data with exponential or proportional relationships. Then there is another one we call harmonic mean. The harmonic mean is used when dealing with rates, ratios, or average of rates. It is calculated by taking the reciprocal of the arithmetic mean of the reciprocals of the values. The harmonic mean is commonly used when calculating average rates, such as the speed or efficiency, or when dealing with data involving rates or ratios. Finally, there is what we call weighted mean. Weighted mean is used when different values in dataset have different weights of or importance. It is calculated by multiplying each value by its own corresponding weight, summing the weights values and dividing the sum by the total weight. The weighted mean gives more emphasis to values with higher weights, and it's useful when certain values carry more significance in the analysis. As I said, let us go back to arithmetic mean, because it's the commonly mean we use in our daily lives. And I'm going to give an example of arithmetic mean. So this is the average of scores under study. It is also known as the arithmetic mean, or symbolically, we just call it the mean. In this case, there is in a class, the students have done an exam. And in my example here, the marks that I have here are for 5 students who are what they have scored in chemistry. The students have scored at 5, 68, 85, 32, and 50. So the average mark obtained by the student will be 35 plus 68 plus 85 plus 32 plus 50 Then you divide by the number of students. In this case, there are 5 students. So I divide that sum by 5. I'll be able to get 54 as the mean mark. So generally, when you have items given as x1, x2, x3, x4, and you go up to the xn here representing the entire population, then their mean will be given by the formula summation of all the items in X. And you can use CC now, I've used sigma. And the sigma here represents summation of all values in X divided by N, which is the entire population. The above formula is used for calculation of mean in case of any grouped data. But what if we have a grouped data? Grouped data, like, look at the scores here. These are 35, they are supposed to be 50, not 35 students. They're supposed to be 50 students in a class. And these 50 students have scored these marks, and they have grouped the marks from 70 to 74, 65 to 69, 60 to 64, and going down up to 25 to 29, and the number of students given below each mark. So how do we proceed to get the mean of this mark? We have to draw this table, but in the way I have represented it here. See, I have my scores. Those who scored between 70 and 74, there are 2. Those who scored between 65 and 69 are 4. Those who have scored between 60 and 64, there are 5. 55 to 59, there are 6. 50 to 54, there are 7. 45 to 49, there are 7. There are 11. 40 to 44, there are 9. 35 to 39, there are 3. 30 to 34, there are 2. And 25 to 29, 1. So the first thing we have to do here is to get this point X, which I call the midpoint. How do you get the midpoint? Take 70 plus 74 and divide it by 2. This one will give you 72. Then 65 plus 69 divided by 2. You will get 67. Then 60 plus 64 divided by 2. You get 62. Then 55 plus 59, and you divide by 2. You will get 57. You do that up to the end. And these are the results you are able to get. Forget about this. It's a mistake here. It's not supposed to be here. It's supposed to be here. Then the second thing now, you have to take the frequency and multiply by what you got in the X column. So this one will be 2 times 72 will give us 144. Then 4 times 67. Then 5 times 62. Then 6 times 57 up to the end. Then when you fill this, what you'll have to get 144, 268, 310, up to the end, up there, fill from up there to the bottom here. And I said this one is in the wrong column, is supposed to come in this column. Supposed to come in that column. So we are going to get now the mean equals to the summation of fx over the summation of f. What I'm saying, frequency. So this one is supposed to come this. So this one will be 2,525 over 50. As you can see, I've written it well here. Our mean being that summation of fx is also our mean become 50.5. Our mean becomes 50.5. Then let us look at various characteristics of mean when you are using mean as a measure of central tendency. We look at various characteristics of this mean, and we will say that mean is computed on the basis of all the observation. When you are looking for mean, it includes every other observation in our data set. And the second characteristic is that mean is sensitive to extreme values. The mean is influenced by extreme values or outliers in a data set. And a single value, usually large or small, can significantly impact the value of the mean, potentially skewing its interpretation. Mean is also has a unique representation. The mean provides a unique presentation of the data. It condenses the entire data set into a single value, allowing for a concise summary of the central values. Number 3, mean is affected by the sample size. The mean is usually affected by the sample size. As the number of observation increases, the mean tends to stabilize and it becomes more representative of the population mean. Number 4, mean preserves the total. The sum of deviations of the individual value from the mean is always 0. When you take mean and you subtract from these values, let me just show something here. When you take this mean, we got the mean is 50.5, and you subtract this from 50.5, then you subtract from every value 50.5, 50.5, you subtract to every value and you sum all the answers. The answer will be 0. The answer you get here, the answer you get here, the answer you get here. And then you decide to add all the answers you have gotten up to this. When you add all the answers, you'll get the answer being 0. And that's why I say that mean preserves the total. The sum of all the deviations of the individual value from the mean is always 0. This property ensures the mean preserves the total value of a data set. If you get it's not 0, then there must be a problem. Also, mean has a character for using interval and racial data. Where the interval between values are equal and meaningful, it may not be suitable for the nominal or ordinal data. As the mathematical operation required for calculation, the mean may not be applicable. So we use only interval and ratio data when you're calculating mean. Mean is not robust to skewed distribution. Mean is sensitive, as I said, to skewed distribution. In cases where data is heavily skewed or exhibit an abnormal distribution, the mean may not accurately represent the central tendency. And here, we should use alternative measures such as the median or mode where more appropriate. The final characteristic for mean is that it is subject to sampling variability. When estimating the population mean based on a sample, the sample mean is subject to sampling variability. The variability of the data and the sample influences the precision of the estimate. We will look at this in more detail when we will be dealing with advanced statistics. The other measure of central tendency is mode. The other measure of central tendency is mode. What is mode? Mode is defined as the score which occurs most frequently in a distribution. In other words, mode is the point on the score scale that it corresponds to the maximum frequency of the distribution. We can also be able to calculate the mode for ungrouped data and also mode for the grouped data. Here, I have scores for 10 students. And these students' scores are 30, 35, 25, 40, 35, 45, 40, 35, 28, and 34. Now, the maximum frequency, the one that high appears many times, because you look, there are those who are appearing, but they are not appearing maximum time. For example, we look at 35. 35 appears 1, 35 appears 2, 35 appears 3. Let us look at 40. 40 appears 1, 40 appears 2. So 35 appears maximum compared to 40. So 35 in this case is our mode. 35 in this case is our mode. Because you compare the two that are appearing most frequently, 35 appears maximum frequency. Also, we might get scenarios where we have grouped data. I've had people just picking. For example, when you are given a grouped data, people just keep picking the one that has the highest frequency. No, that's wrong. There is a formula for calculating the mode. And this formula is mode equals to L plus, open the bracket, Fs on the numerator, all over Fp plus Fs on the denominator, close the bracket, times I. We will see in details how we can be able to apply this formula. L equals to the lower limit of the model class. Lower limit of the model class. And the model class is the class in which the mod may be supposedly appear or lie. We have Fs. Fs is the frequency of the class succeeding the model class. Frequency of the class succeeding the model class. Fp is the frequency of the class preceding the model class. And finally, I is the class interval. I is the class interval. Now, let us move on to apply this formula to our data. The data given here, we can see coming from the same data we have just used in our previous example is what I want to use. We have here, the one I'm representing in the yellow is the model class. Because when you look at this class, it has the highest frequency. Other classes have 2, other 4, 5, but this one is having 11. This one is the one with the most highest frequency. So in this class, it means that our model class is 45 to 49. So we are going to apply our formula. Our model class L is, as shown, 45 to 49. But we don't use now 45 to 49. We use the boundaries. This class has the boundaries, and the boundaries are 44.5. That's the lower boundary, and the upper boundary is 49.5. We always use the lower boundary. So the lower boundary is what we are going to use here as our model class L. Then we have Fs, Fp. Fp is the class preceding the model class. So our model class is 11. So the number above it is the one that precedes. So it is 7. And we have our Fs. Our Fs is 9. This is the number that succeeds the model class. And then we have our I. Our I, we take the upper class boundary, which is 49.5, minus the lower class boundary, which is 44.5. It gives us 5. So that one is our limit, our class interval. Our class interval has 5. So we are going to take 44.5 plus open bracket 9 on the numerator all over 7 plus 9 close the bracket, then multiply by our class boundary, which is our class interval, which is 5. So you see, we have done the substitution. We can go back again to bring it back. Our lower class boundary is 44.5. So that's what we write, 44.5 for the model class, plus we open the bracket, we put the succeeding class from the model class is 9, plus 7 on the numerator, and on the denominator we have 7 plus 9. Then we close the bracket times our class interval, which is 5. So when we do that, then we will have 44.5 plus 2.8125, which will give our mod as 47.3125. This is the formula for us to use when we are calculating our class boundaries, our model class. We don't just go to the data and just summarily we say that the one that's having the highest frequency is 45 to 49. So we just pick 45 to 49. We have to do some calculation the way we have done them here, and that is it. What are the characteristics of the model the mode to be used? What are the characteristics of the mode as used as a measure of central tendency? While the mode provides insights into the most frequency values in the dataset, it may not always provide a complete representation of the data, central tendency, or variability. Therefore, it's often used in conjunction with other measures of central tendency, such as the mean and the median, or to gain more comprehensive understanding of the data. The mode as a measure of central tendency possesses several important characteristics, and they include: it is the most frequent value. The mode represents the value or the values that occur most frequently in the dataset. It identifies the peak or the peaks of the distribution, indicating the most common observation. Secondly, most frequent value. Mode represents the value or the values that occur most frequently in a dataset. It provides the peak or peaks of the distribution, as I said, indicating the most common observations. In order for us to use this data, we use the nominal type of data. Nominal type of data. And it might be limited to be used by other types of data. And the mode may not be unique. Unlike the mean and median, the mode may not be a unique value. A data set can have multiple modes. When you have two modes, it's called bimodal. When we have several modes, it's called multimodal. And where there are multiple values with the same highest frequency, then we can have a problem of picking, which is the representative value. So mode is not a unique value. And it's also insensitive to extreme values. It's so insensitive that the mode is unaffected by extreme values or outliers in a data set. It focuses on values that occur mostly frequently, regardless of their magnitude. Mode is mostly suitable for qualitative data. When we are analyzing qualitative data, we can mostly use mode, because this one can only identify the most common category or respondents in a survey that are appearing there mostly. Also, as much as it is not affected by extreme values, is less unaffected by skewed distributions. Unlike the mean or the mode is less influenced by skewed distributions and does not require asymmetric distribution. It can identify the central value even if heavily skewed or non-nominal data. Also, it has limited information about the spread. Where you are looking for the spread, how the data is spread, mode cannot identify it. The mode does not provide information about the spread or variability of the data. It solely focuses on identifying the most frequent value or values and does not consider the distribution of other values. The last one, in cases a dataset may not have a clear mode if all values occur with equal frequency. So we say mode may be unreliable. Mode may be unreliable. Additionally, the mode may not be a reliable measure of central data if there are small sample size and if the dataset has significant variability. Let's move to median. Let us move to median. Median is the number of observation, the middle value. And in order for us to calculate the median, we take the nth value for odd, for those that are even, not odd. For those that are even, we take the number of observation plus 1 divided by 2. Then we'll be able to get the number of mod. Let us get from an example. There are 10 students who have scores in history. But in order for you to use median, the first procedure is to order the data. For example, when you look at this data, these are just values, but you must be able to order the data in order for you to use the median. So I have ordered now my data, because when you look this data 65, 30, 40, 25, 50, 48, 56, 35, and 60, there are 9 values. They are not 10. There are 9 values. So when you are ordering them, you'll have to start either with the least or to start with the highest, but with always to the median, start with the least. Start with the lowest. With median, start with the lowest. So we have ordered them. We have 25, 30, 35, 40. So these ones, I've ordered them now. They are 10. I've ordered them. So when you're looking at them now, you have to distribute them evenly. So in this case, because there are 10 numbers, divide them into 2 equal parts. We have 1, 2, 3, 4. So these are divided on the lower part. And you have also 4 on the upper part. So you have 25, 30, 35, 40. And then you have 50, 56, 60, and 65. So you have remained with the 2 numbers in the middle here. You have remained with 48 and 45. So after these 2 numbers, 48 plus 49, and divide them by 2 to get 48.5 as your median. So you have distributed this data into 2, and as you can see, you are able now to get your mean from the 2 numbers that are remaining. If you had 9 numbers, then you'll have to divide these numbers into 2 equal parts. You remain with only one number in the middle. Then you'll pick on that number. But if you have 2 numbers, like in my case here, you have to divide those, add those numbers and divide them, and then you'll have to get your median. Let us consider this course of 9 students in English test. So when you have these ones, you have to order them. So you are going to start with the 15, then 25, then 28, then 37, then 46, then 43 before you go to 46, 43, then 46, then 50, 52, then 60, 56, and then 60. So there are 9. So in this case, divide this data into 4 parts and also into 4 parts. You remain with only one value in the middle. So your median will be 43. The value you have remained with in the middle there. So first of all, you have to order your data for ungrouped data. But when it comes to grouped data, you have first of all to arrange the data to come up with a table like the one I have on the screen. Then you introduce another part of column. You come up with another column, and this column is called CF, cumulative frequency. Cumulative frequency. Cumulative frequency. This column will assist us to get the cumulative frequency of this data. So we start from the least to the highest. So we have 1, and this one we add to the one that follows here. So we have 1 plus 2 is 3. So this 3 we add on the number that preceded, so we are going to get 6. So this 6 we add on this other number, we get 15. 15 add to this other number that coming next, we get 26. 26 add to this other number, you get 33. That 3 add to this other number here, you get 39. That 9 add to the frequency that follows there, you get 44. 44 add to this frequency that adds there, we get 48. 48 add to the last frequency there, you get 50. That's how you calculate your cumulative frequency, and can see them arranged very well here. Now, we look at these numbers we have. We look at these numbers we have. The cumulative frequency is 50. So if it's 50, we have to look for now the median class, and we get to this median class. So we get a median class by taking 50 divided by 2, and 2 is 25. So when you go back to our data, we realize that the first cumulative frequency is 1. Then when you add it, you get 3. When you add 3 to 3, you get 6. When you add 6 to 9, you get 15. But now, when you add 15 to 11, you get 26. So the 25th is in this, the 25th value is in this 26. That's where we have the 25th value. So now this one becomes our median class, the whole of it. Our median class becomes this. So it's very important that when we identify our median class, it becomes very important, and I've labeled it yellow so that you can be able to see it. Now we are to apply a formula, and this is the formula we apply. This is the formula we apply. L always means lower class boundary, bracket, CF over 2 minus succeeding frequency, minus succeeding frequency. In this case, the succeeding frequency is 15. The one that is below is what we are calling the succeeding frequency. Is below there, minus 15. Then this is the value we are going to use, this 15 here and this 11, the frequency. These are the two values we are going to be using most commonly in our calculations. So in this case, we are going to have the median. 44 is our lower class boundary, plus bracket 50. 50 is our final value we got in our CF, in our cumulative frequency. And 15, I've shown you where I'm getting it from. It is the succeeding value. It says exceeding value here, 15. Exceeding value in our cumulative frequency, and 11 is the frequency where the median class lies, and times 5, which is our interval, because I told you that 49, the upper class boundary minus the lower class boundary. When you subtract them, you get 5, and that's why we have this 5 here. Then when you work it out, our median will be 49.045. Our median will be 49.045. What are the characteristics of median? What are the characteristics of median? While the median provides a useful measure of central tendency, it might not capture the full range of variation in the data set. Therefore, it's often used in conjunction with other measures such as mean and mode to gain a more comprehensive understanding of the data. So the median as a measure of central tendency possesses several characteristics, and the characteristic number 1, it is the middle value. It is the middle value of the data, and it divides the lower data set into 2 equal halves with an equal number of values below and above it. Also, it's applicable to all data types. Median can be calculated for any data type, which include ordinal, interval, ratio data. It's not limited by the type of measurement scale. It is insensitive to extreme values. It is not affected by extreme values. The median is less influenced by extreme values or outliers in the data set compared to the mean. It is determined by the position of value rather than the actual magnitude. It has a unique representation. Unlike the mode, which may have multiple values, the median is single value in a data set. It provides a single representative value for the central tendency. It's suitable for skewed and for skewed distribution. Sometimes we get a skewed distribution, so the median is particularly useful for analyzing skewed data, where the data is not symmetrically distributed. It's less affected by extreme values, and it provides a more robust measure in such cases. It preserves order of information. The median retains the order of information of a dataset, does not require the exact measurement, but it focuses on their respective positions. It's less affected by sample size. The median is less influenced by sample size compared to the mean, and it can provide a suitable estimate of central tendency even with small sample size. It provides information about the spread. Median provides information about the spread. The median does not only provide information about the central value, but also gives insights into the spread of the data. It divides the data sets into equal halves, reflecting the distribution, symmetry, or the skewness of such a data. Easily to understand and interpret. The median is straightforward and easily to interpret. It represents the values that separates lower and the upper value in the data set. Thank you very much. We come to the end of our lecture. Let's meet in the next class where I'll be able to represent variability, in the data, and we'll be looking at the variance, we'll be looking at the range, and we'll be looking at the standard deviation. Thank you, and God bless you.